So in LCD, especially like this LCD thing, you might have seen in your microwave oven, like in many of the applications, like even uh, older, if you had seen like the initial mobile phones, like 1100 and all. So that used to work on this basic principle of dot matrix displays. Okay, so LCDs are preferred compared to your 7 segment display because of their capability to have more information in the sense. Like when we have like 7 segment display, for instance, so you can actually play with these combinations only, right? I mean, like you can have numbers, but if you want to have some characters, like you cannot have like the Z, or if you want to have different characters and all, it is not possible to display with 7 segment. Right? So that's where in LCD, these are sequence of matrix. Like you can think of like small matrix nearby. Uh, this way, like it's a matrix. So here you will have all the matrix. So you can actually create more characters here compared to your 7 segment. Like if I want to have something like uh, even the Kannada character, if I want to display, I can just display with these combinations. Like if I want to have some characters like J, okay, I mean like I can go with these combinations. Like I can bring something like this, right? So in between also we have various dots, pixels. So this is like how your image processing we use, right? We will have various pixels. So the basically LCD works on the concept of pixels. Okay, so we can easily control these pixels and we can display the characters as. So major thing is versatility, like compared to your 7 segment display, and like we can have more information, right? So basically, like we will have like in the character display, what you might have used in your labs, it will be 16 pixel, okay, 16 cross 2 combination. In the sense, it's not pixels, sorry, it's like 16 characters, 16 characters and 2 lines. I mean, you might have done this experiment in the lab also, right? You can display 16 character in one row, right, in one line, and another 16 character in another line, and such 2 lines will be there. I mean, this is one example. There are like 4 line LCD display, 6 line LCD display. That those are also available in the market. Okay. And if you consider like LCD devices and also, which will be like, I mean, if you go for high-end LCD, it will be high cost. But this basically, this particular 7 segment, the character LCD, what you get in market, which is of low cost, you'll get it like 150 to 200 rupees, right?
Yes, sir.
So one example I have given in like this, this is used in microwave oven, things like that. There are also other examples which you might have seen. Like if you have seen your electric meters nowadays, that will come with these kind of
So the voltage system also.
right, right. I mean, even if you have
The
that.
voltage current, the electricity bill they come to
Right,
measure.
right. That's what actually your home electricity meters. You see that nowadays you see that display,
Yes, sir.
right? And if you go to the POS, like in the supermarket, like DMart and all, you might have seen this small display which will be keep displaying whatever he has entered there. So they have actually one additional display where you can actually see these characters. So that these are the some application where we actually use in the real time. So recently, I was also consulting to one startup in bank. So there, they had some application like some waveform generator. So they wanted to display something like what waveforms we are generating on display. So we were using like not 12 cross 16. We were using it's not 2 cross 16. It's 4 cross 16 because like we can have more characters there.
Okay, sir.
So I'll display one image where it will actually show the overall summary of what we have discussed so far.
Yes, sir.
So you can see that like this is how you might be seeing the LCD display, right? So you will have like 1 into like total 16 characters and such 2 lines usually we have, right? 2 lines. And each line comprises of 16 display characters. It's like we have 16 display characters. And each character, right, it is basically, it will, as I said, it is like dots, right? It's basically dots. So like these dots will glow or it will not glow. That's where you will see the character displayed. So such 5 dots and 5 cross 7 dots, right? You will see each character, like if I consider one particular character, in that we will have 5 cross 7 dots. Okay, that dot is nothing but pixel. I mean, if you know that like the LCD TVs, what you see, that is actually extension of this display itself. I mean, in the LCD TV, what you have in the house, so that also works on the pixels. But here in this particular LCD, it's a black and white. I mean, it can be black. But in the TV screen, what you have on home, that might have like multiple pixel capability. Same pixel can change its color. It can be like combination of multiple color where you see that. Yeah. So, I mean, the conceptually, whatever techniques we use here in this case, techniques we will be using in those also. Okay. So coming to the architecture, internal architecture of this LCD. So if I want to program these characters, right, like these pixels, so we should have like huge memory, right? So that's where we have something called DDRs, double data rate RAM. So DDRAM, where we actually store like it acts like a buffer. I mean, if I want to store certain characters, it acts like a memory for me. And we also have one ROM, which used to store the configurations. Like you may say that like 1 line, 2 line, like various commands we will be giving to this LCD. So those configurations you will be storing in ROM. And for controlling these pixels, right, we have one shift registers for controlling the pixel shift register. Okay. And finally, we have one controller. Okay. So a LCD itself, it doesn't have any intelligence. So you have to control these pixels, right? I mean, whenever I say I want to control this character, then there is actually a lot of control logics are required. So if you push all this control logic towards the microcontroller which you are driving, like LPC2148, then LPC2148 will be like keep doing this job itself, controlling each pixel. But always this processors or controller what we put it in design that is intended for sample application, right? Our actual aim is to do some real time processing, like maybe analog data or sensor data capturing. It has to do its objective, what we have defined for it. But this display is just whatever the result we got. If I want to display it to the user, for that purpose only I'm using this. So our microcontroller's main job is not to work on display characters and all. That's why one small microcontroller will be very reasonable LCD display itself. So which will be like doing this operation through some communication protocols. Like one of the communication protocol what we have seen now is UI, right? So something like that. We will talk to this display. We talk to this LCD display where it will communicate to that LCD and we can display the character we want. That is the main objective of this controller.
Yes, sir.
So here you can see I said that there is a ROM that is also called CG-ROM, character generator ROM. Okay, so which actually contains the information about these pixels, what character has to be displayed when I send some ASCII characters. Okay.
So, but where is this used, the CG-ROM?
No, this is inside your this entire thing, right? This is a circuit inside your LCD.
Okay,
This
yes.
together will form your LCD. So in the front end, you see that LCD pixels, but back end, right? These operations will be happening. These components, which will help you to display those characters. Clear?
Got it, sir.
So whatever the data I want to display on the LCD, for example, in this character, like I want to display A. Okay. So then what usually we do, that data, right? So what is the ASCII character or ASCII code of this A is 65. Okay, 65 is the ASCII character. So what we do, this 65 we write into DDR. First we write into DDR. Okay. So in the DDR, right? In the DDR, for each character, one location is assigned. So for example, if I want to write to this location, I have to write to that like first location for first character. So on, right? So actually
Yes,
what
sir.
I do, yeah. So first 40 bytes are located to like 0 to 39, right? So that is located for the first line. And next 40 byte is located to second line. So if I want to write anything, like whatever the data I want to write in these characters, I will write into that DRAM. DRAM. And from the DRAM, it will push into the display. Okay. So this is actually about the basic of your LCD display. Now, this LCD display as such, it's a separate module, right? Now, how I can interface this with the microcontroller? Like I have one LCD display, I have LPC2148 microcontroller. How to interface this? That is the main scope of discussion. Because this component wise, we need not much bother. I mean, that as an entire whole module system, we get it. But the major concern or major scope of our discussion should be on interface, because this is available for us. LPC2148 is available. How I can talk to this LCD through LPC2148. So before coming to that point, let's look into the pin diagram of this LCD. What are the various pins are there? If you see here, total 16 pins are there. 16 pins are there in the LCD. First is ground, then VCC, V0, RS, RW, E, and D0 to D7, and we have VB1, VB0. Each one we will discuss in detail what exactly is each pin does. So first is actually we'll come to this RS. So ground is straight away we know that like we have to uh, ground that pin. If you see here, it is grounded, and the V out, right? So that is actually we say it as contrast control. Contrast, in a sense, like it may look now it is looking very dark. So you can change the contrast of it. Like in the usual LCD, you will have option to control that, right? Same way here also we have option. And coming to this RS pin, right? RS is also called register select. Register select. So if you write 0 to this RS, then it means we are writing a command. We are writing command byte to LCD. If we are writing 1, then we are writing data byte to LCD. What do you mean by command? For example, I have displayed 7 here. I have displayed 7 here. So then if I want to erase this 7, if I want to erase this 7 and I want to clear the display, then what I have to do? I have to basically give some command saying that erase all the things, right? So these are actually defined by our command registers. And when I say LCD data, like if I want to display 7, so that 7 is the data point. So telling the LCD that erase that or like go to the next line or go to the next character, blink this LCD. So these are we call it as commands. But data is what character I want to display. That we call it as uh, like data. Okay.
Sir, I couldn't hear that word. Can you repeat it?
So if you want to have that, like what LCD has to do, like blink or like go to next line, go to next character, or erase all this display, that we call it as command. So RS we make it 0. If I want to send the data, like I want to display 7, here I want to display 8. So this data we send, right? What to display? That we call it as data, LCD. That's where we categorize. Is it a command or data?
Got it, sir.
Next, we discussed about this pin, that is 4th pin, that is uh, register select. Next pin is read write. Read or write. So actually, if this pin is 0, then we are writing to LCD. If this pin is high, then we will be reading from LCD. So, but many a time we will not read back anything from LCD. Okay. So many application like will be just keep sending the data and displaying it. So this read write data a pin will be grounded. Always when I say it is grounded, I'm making that into always 0. Okay.
Yes, sir.
Next pin is enable. So enable is something like it should be from 1 to 0 pulse. 1 to 0 pulse. In the sense like you should give something like this. It should be high. then 0, and it should go back to 1. So this pulse is required to perform read or write to the LCD. Okay.
Yes, sir.
So the condition is the enable should be high, minimum for 450 nanosecond it should be high, and then from here to it should go low. It should be something like this. This minimum 450 nanosecond is very important. High to low pulse. So then what happens? Whenever this happens, right, high to low pulse, then the data will be returned to your LCD. So that's where we call it as enable. You can see this E, right? Sixth pin. Sixth pin. So for clear, we saw a register select, read write, and enable. And fourth one is data. D0 to D7. 8-bit data. It's a 8 pin. It's a bidirectional. You can write also. You can write the data also. You can read back also. It's a bidirectional. When we say bidirectional, you can actually read and write together.
Got it, sir.
So now coming to LCD. So I mean, you have like we have seen most of the things, but except like VCC is something like it's like voltage what we supply, and we have contrast pin to control the contrast of the LCD, and rest are like straightforward. I mean, it's like ground, VCC, and data what we have discussed. Okay, so now uh, our scope of discussion is, as I said, how to interface to our LPC2148, right? So let me just so if you see here, port 0, 20th pin, I have given to the RS. What do you mean by RS? Just now we discussed.
So the reset one?
Not reset, it is register select. We have command or data, so it is a register select. And what do
So
you
next is
mean
the
by
enable pin.
yes? What is the condition for enable? It should go from high to low.
High to low, sir.
And this high should be minimum 450 nanosecond.
450. Yes.
And if you see here, one surprising thing introduced, like only 4 bits are used, right? D4 to D7, but D3 to D0 they haven't mentioned. This is a special case. So if it is like D7 to D0, then how many pins you require? Require 8 pins. So in order to avoid that, in order to avoid 8 pins and use only 4 pins, like we use something called like half mode. I mean, we will not send the complete 8-bit, we will be like just sending the nibbles. That is 4-bit mode on 4-bit mode of LCD. Okay, where we can just use 4 data lines instead of 8 data lines. We are just using D4 to D7. That is 4 lines. Okay, and if you see here, VCC and VB light, it's a backlight. VB light means backlight. The green light what you see in the LCD, right? That's a backlight. So if you don't connect to 5 volt, then backlight will not glow. And you can see VEE, right? That is actually contrast. So whatever the voltage you give here, so it's a voltage divider circuit. So if it is like straightforward, if you are connected here, so it is high contrast, direct 5 volt is connected. Slowly when you bring down through this resistor, so VEE will keep decreasing and your contrast also will keep decreasing. So that is like contrast control. Okay. And if you see here, the read write pin is grounded here. That means always I am writing. not reading anything.
Okay, sir. So what is the R or W sign?
Read or write. Read or write. But here I am only writing. So that's why I've grounded. So if it is like, if I want to write, always it should be 0. If I am reading, it should be 1. But what I'm doing, I'm only writing to this image. I'm not bothered about reading them. So next we will see some of the LCD, major LCD commands. First is clear display. So this is actually D7 bit. This is D0 bit. If you make D1 bit as high, and so actually what you have to do, so here which part selects whether it's a command or register, command or data, like this register select, right? So you have to keep this in the register, the command mode, and then if you send this data, 8-bit data like 0000001, then it clears all the display. It will make that display as blank display. Okay.
Yes, sir.
Next command, cursor home. So second bit if you make it high, last bit is ignored. I mean, it can be 1 also, 0 also, it doesn't matter. If you make second bit high, irrespective of what right side we have, so it returns the cursor to home position, also returns display being shifted due to original position. So you have this LCD display, home position is like first location. So your cursor, right, it will start blinking here. So your cursor started return to home position. Next, we have this entry mode set. So cursor is like, if you make this as low and third bit high, then it means, and like shift last bit 0. So cursor is in decrement position. So in the sense, so you will be starting from last location, 16th location for instance, then cursor will be keep decrementing. If third bit is high and ID is 0. If it is third bit is high, ID is 1, so then cursor will start hopping right. And whenever it shifts, whether you want to see that transition, that can be decided by S0 or S. Okay. If you want to switch off the display, then as soon as you make this 0, like fourth bit is high and this is 0, display will be off. If the display is on, if you want to make the cursor high, then make it high. If you want to show the cursor and like if you want to blink it, so you can blink it through this. And if you want to shift the cursor, like left, right, move the cursor, so you can use 0001, that is actually fifth bit high. And I shown you in LPC2148 we have connected only how many bits?
So 8 bits.
Out of that 8 bit, if you see this circuit, if you see here, basically we have connected only 4 bits, correct? This is, I said, like we are saving 4 bits. That is actually comes from this statement. You can see we select one mode, like we have two interface mode. One is 4-bit mode or 8-bit. Here we use 4-bit mode. So that's where like we have to initially give the command 0. 6-bit 1 and 7-bit as a 5th bit 0, then it will be 4-bit interface. Okay, and by default it is 5 cross 7 dots, but there are some exception where you can display the special characters as well. So you can go for like f equals to 1, then it will become 5 cross 10 dots. So it's a dot selection, the function set. Okay,
Yes, sir.
so whenever I want to write the data, any LCD program, so usual configuration, what we do, first we actually set the function because we want to make sure that like it is 8-bit or 4-bit. It depends on like your connections, right? So first step, what we do is we set the function. So then we send display on command, display on command. Then finally we send clear display command. Once these 3 steps are done, function set, display on, clear display, then we start sending the actual data. We start sending the actual data. So for example, in the function set, if I send 0x to 8, what is the meaning of it? 0, 0, 1, 0, 1, 0, 0, 0. So this bit corresponds to, it's a function set. So DL is 0. What is the meaning of it? It means,
So it clears it.
no, DL, so here DL. So it is a 4-bit, I meant it is 4-bit interface. And N is 1. I'm using 2 lines. Both the lines I want. And F is also 0. That means I'm using 5 cross 7 dots. Okay. Now next thing, I have to send display on command. That is actually 0x0c. Which command says display on? So this, right? So this. So here all are 0 and display on. See, D, this is 1, 0. And if I want to on the display, switch on the display, this has to be 1. B, blinking cursor, I will make it off. Or like I can make that also on. Okay, display on, this is 1. And C, cursor on or off. I'll just switch it off. 0. Blink also, I'll switch it off. So this is nothing but C, right? Display on and cursor off.
Yes, sir.
So clear display, how I can do that? Here.
So 1,
Clear.
0.
Yeah.
No, just
0, 1.
1.
Just
Okay.
0x0.
Yeah, 0, 1.
Right. So then it will clear the display. Then I should make RS into high, right? So the RS, like next I will start sending the actual data. I have to make RS high. Then I have to send the ASCII character of each data. Okay, whatever I want to display, right? I'll be sending that. Okay, and that too. It should be to the various position, like position of DRAM. Like it can be 0x80 plus CAD position for first line, 0x30 plus character position for second line. So which line I want, which line of the which character I want to display, right? Then that address I will send and I will write it. So if it is like third and fourth lines are, then I have 94 and D4 also raised. But I mean, when we go through the program, we will get a clear idea. Okay. So I mean, this meeting will end now. It's a 40 minutes meeting. What I'll do, uh, we will take like 10-15 minutes break, and I'll share you a new link. You can join that. We will continue. We will complete the program today.
Okay, sir.
Okay. Okay. I'll ping you a new link in some time.
Yes, sir.
Okay. Thank you.
Thank you, sir.